So I'm printing on the Baffle from my other speaker. I guess I want to show you guys how this looks. So these are crisscross lines. Those are supports. Infill. This is called infill. These are supports for the holes because I'm printing it upside down, and then later the supports come out, and kind of looks like this. The supports come out, and then this is where then the tweeter goes inside that hole to make it flush with the baffle. So supports take extra time to print. This print takes 9.5 hours, almost 10 hours. So usually per each one, yeah, you heard it right. I print these a little bit slower. I don't want speed to mess anything up, so I don't mind waiting an extra few hours to do it right. You also want to print these upside down, meaning the front facing part of the baffle that's you're gonna be looking at is pointed downwards on the printing plate, because this bed is heated at 55 degrees Celsius, so that heat will make it nice and smooth. It smooths out the front baffle. If you did it the other way, like I first did when I was getting into it, you will see the printing marks. It will not be pretty at all. So you just a little tip is to just simply, in your software, flip it so your front is actually down. So print it upside down. And you have to also, when you do that, you have to activate supports. So this is the support for the holes, and those are again supports. And these are infills. Infills use a special pattern so that the part is not printed in 100% plastic. It will take a long time. I don't know, maybe 30 hours if you did it with 100% infill. It will take an extremely long time, and it's just not something to be practical, I guess. Now, if you had a machine, like if you're using this for prototyping and then you send it off to the manufacturing process, and they had a injection molding machine, then that's a different story, because it just kind of goes like this. The two clamps, they make a die for it, and then goes closes, and makes the part, and the part spits out. But that's an expensive process. It's something that you would only do if you were in some kind of a business, right? Mass producing these, because you have to create a die. So the die process is a master die that would make these parts, right, in the machine like I just described. The whole thing is very expensive. You have to hire people, make a die. If the first iteration isn't quite right, you have to make another die, and so on and so forth, just kind of like with this, until you get perfect. Once you get the die perfect, that's your master die. You can make copies from it, and then you can mass manufacture these. But that's, for a custom job for someone, for a speaker like myself or someone else, that's just not that doesn't make sense, because, like, for example, I'm using these specific tweeters. Someone else might want to use slightly different tweeters, and so on and so forth. If the outside is approximately 4 inches in diameter, and it will fit in here. But if it's bigger or smaller, I have to resize this and then do another prototype, make sure it fits both diagonally and the depth of whatever differences in the tweeter. Anyway, so this is what 3D prototyping makes sense for, like, projects like this small scale. Now I'm printing at something called PLA. Okay, there's another thing called PLA Plus. The Plus, I guess, must be a little bit better. Now there's a material called HG, which is a little bit more difficult to print with, a little bit more finicky. You have to get the temperature just right for everything. but that material is stronger. PETG would be much closer to what the original material is that the baffles were made out of, and I might play around with that in the future when I order some PETG material. There's a few other ones. There's also materials now where they're coming out where they're mixing PLA with carbon fiber. I haven't tried that, but that's a very interesting material. Carbon fiber will make it very strong. I might play around with that in the future. Well, anyway, now you know how this works. I have a little computer here connected. This is a Raspberry Pi, whatever, B plus, I think. It's not the latest greatest. And that has an Octopi image. You can Google Octopi. What that does is it has an image, a Linux image specifically dedicated to the printing, and you can remotely, has SD card in there for the operating system, and you can on your browser connect to this. You can drag and drop print straight to this, and then that is connected with this cable and interfaces with the printer and sends its commands. That's how I'm actually printing this. The alternative is to actually put an SD card in there. There's one in there. It moves, so maybe you can see it, but you put an SD card in there. You have to remove that SD card, put your file on it, put it back in, and then you can print it directly from your printer. But this is just more convenient. Plus I have a camera here, and I can remotely kind of keep an eye on it. I don't have to be here just to make sure the print didn't mess up or something. Sometimes weird things can happen, or you didn't run out of spool, didn't run out of material. Yeah, so if you're interested in how these are actually made and printed, this is it. It's kind of a mesmerizing process. You can lost, I guess you could be lost staring at it, but don't get lost, people. Walk away. That's another amazing thing. Once you dial on your printer, everything is correct. And this is an older printer. This printer is like 4 or 5 years old, so it doesn't have a lot of the automatic features that you can get in printers now, like auto leveling. It doesn't have it. I could get it if I wanted to mess with it. I could upgrade this and the software and add auto leveling. But at this point, the printer is like, you know, so many years old that, and I upgraded the springs underneath here. I only level once every year or two. You know, it works that well that this auto leveling doesn't actually mean anything to me. It's not an issue for me. If your bad printing bed underneath has really good stiff springs, it's an overkill to auto lever every time or every couple of days. Literally, there's nothing there to change. Yeah, I guess that's all I want to show you guys. Cheers.